Happy Friday! Today we will be discussing the product rule. As we go through these, please make sure you are filling in the notes. We should know that product means multiply. So we are going to start looking at multiplying two monomials or more. A monomial is an expression with only one term. Since we're talking about exponents, we're going to be talking about multiplying two monomials. One important thing about those is they're going to be expressions with the same base but different exponents. As an example, let's look at 2 to the 5th times 2 to the 6th. You should know that these are both exponential form. To figure this out, we can actually make them an expanded form. So we know that 2 to the 5th means 2 times 2 times 2 times 2 times 2. And we know that 2 to the 6th means 2 times 2 times 2 times 2 times 2 times 2. Notice that there was a multiplication sign between the terms, which means we'd put a multiplication sign between the expanded forms. If you look closely, I just see a whole bunch of 2's being multiplied together. So what's a quicker way we can write that? Well, we can condense this. Our base is 2, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. So this is 2 to the 11th power. In other words, 2 to the 5th times 2 to the 6th is equal to 2 to the 11th. 2 to the 11th power is such a large number that I'm really not interested in its actual value. I just want the exponential form of that. Moving forward, I'd like you to consider how we might be able to do this a little bit quicker. Writing these out in expanded form will always be a good strategy. But in terms of efficiency, maybe there's a quicker way we could get from here to here. Think about that as we look at the next examples. For instance, negative 7 to the 4th times negative 7 to the 3rd. Even with negatives, it doesn't change the way we think about it. Negative 7 to the 4th power just means negative 7 times negative 7 times negative 7 times negative 7. Negative 7 to the 3rd power just means negative 7 times negative 7 times negative 7. Of course, we had the multiplication sign in the center, and once again, I notice that we are looking at repeated multiplication of the negative 7's. Well, that means that we'll have a base of negative 7, which does need to be in parentheses, and we count how many we have. I see 1, 2, 3, 4, 5, 6, 7 of them. So this would be negative 7 to the 7th power, meaning negative 7 to the 4th times negative 7 to the 3rd is equal to negative 7 to the 7th. Have you thought about the quick way to do this yet? If not, that's okay. Take a look at one more example. What do you think 3 to the 2nd times 3 to the 7th is? Why don't you pause the video, try doing it yourself. If you got 3 to the 9th, you are absolutely correct. But let's make sure we're aware of why. So if we look, 3 to the 2nd is 3 times 3. 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3 times 3. I had the multiplication sign in the middle. I see all 3's being multiplied. It looks like I have 9 of them, so it's going to be 3 to the 9th power. So what's the quicker way to do this? How can we say what we're doing here? Well, if you figured out in words what we are doing, Okay? We want to develop a rule that we can use for multiplying any exponential expressions with the same numerical base. It looks to me what we did, we started with 3's as our base, we ended with 3 as our base. So the first thing we do is we keep our base the same. But how can we move quickly with the exponents? Again, writing it out in expanded form is always an appropriate method. But a quicker way to do it is to look at simply adding the exponents. If you look at the examples above, we had 2 to the 5th times 2 to the 6th. 5 plus 6 was equal to 11. Our answer was 2 to the 11th. We had negative 7 to the 4th times negative 7 to the 3rd. We keep the base, we add the exponents of 4 plus 3, and we get negative 7 to the 7th. Same thing with 3 to the 2nd times 3 to the 7th. Keep the base of 3, add 2 plus 7, get an exponent of 9. So just a quick new example, if you were given something like 10 to the 3rd times 10 to the 11th, we would keep the base and we would add the exponents and get 14, and that would be absolutely correct. If you did this not with numbers, it doesn't really change the outcome. A to the x times a to the y. We keep the base, which in this case is a, and we add the exponents, which I don't know what x and y are, so I would just write x plus y as the exponent. If you need to see any other examples, feel free to pause the video, go back and try some of the other ones. If you're ready, flip to the back and try some of these on your own. I'm going to go through them, but you can pause and fast forward the video as much as you need to. Three to the 2nd times 3 to the 4th. I'll keep the base, which is 3. I'll add the exponents, which is 6. 3 to the 2nd times 3 to the 4th is equal to 3 to the 6th. 7 to the 7th times 7 to the 5th. Keep the base of 7. Add the exponents. 7 plus 5 is 12. 7 to the 7th times 7 to the 5th is 7 to the 12th. It even works when you have more than 2 terms. I still have a common base of 15, so I keep that base. I add the exponents, which is 1 plus 4 plus 0. 1 plus 4 is 5, plus 0 is still 5. So my answer here is 15 to the 5th power. 3 to the 8th times 3 to the negative 6th. Even the negative exponent doesn't change the strategy. I keep the base of 3, I add the exponents. And if I have to, I might even come over here to the side of my paper. 8 plus negative 6. If you remember our integer rules, we will actually subtract them and keep the sign of the larger. 8 minus 6 is 2. The 8 is positive, so my answer is 3 to the 2nd power. 3 to the 8th times 3 to the negative 2nd. 6th is 3 to the 2nd. Looking at number 5. Even when the base is a fraction, it doesn't change things. These fractions are exactly the same. So I'm going to keep the base, which is a fraction, and I am going to keep it in parentheses. I keep that base. I add the exponents. 5 plus 3 is 8. 2/3 to the 5th power times 2/3 to the 3rd power is 2/3 to the 8th power. Again, 3 terms. Negative 6 to the 10th times negative 6 times negative 6 to the negative 8th. I do see the same base. This one might be a little bit confusing because the middle one doesn't have an exponent. But I do remember that when I don't see the exponent, there's really an invisible 1, which I'm going to put there so I don't forget. So I'm going to keep the base of negative 6. I'm going to add the exponents. 10 plus 1 is 11. 11 plus negative 8. Again, I might have to go over here, 11 plus negative 8. Remembering my integer rules, I subtract. 11 minus 8 is 3. 11 is the bigger number, so I keep the positive. My answer is negative 6 to the third power. When I multiply these together, I get negative 6 to the third power. Okay, and that really is the lesson. That is the product rule. We keep the base, we add the exponents. We do recognize that in every one of these questions, the base started out the same and it ends the same. So for class Monday, what I would like you to do is I'm going to give you the answer. Think of this like Jeopardy that we did the other day in class. I give you the answer. I'd like you to try and write at least 2 multiplication problems. So the answer is 8 to the 10th. What could be a couple of different multiplication problems where the answer is 8 to the 10th? Good luck. I'll see you on Monday. Stay classy, Math 8.